Who here has heard of Go? I hope all of you, because you learn a lot about it. Anybody use Go? Played with it a little bit? Gone to the website? Tried out some of the code? All right, so fresh. Sweet. So my name is Jameson Little. I work for Spotter RF. AJ over there is actually one of my coworkers. He's our lead of technology, programming, I don't know. What's your title again? Lead software developer.
Whatever I wanted to be.
Yeah, so currently we use a lot of Node.js, and we're thinking of switching over some of our stuff to Go because it's so cool. So hopefully you'll agree with me that it's pretty cool. So first of all, some background. The guys who developed it, their names are Rob Pike and Ken Thompson. There's one other guy, but Rob Pike and Ken Thompson, they worked on the original Unix. They also worked on Plan 9, which was supposed to replace Unix. Parts of that have been salvaged and put into Linux. They've also worked on several programming languages. Ken Thompson actually wrote the language B, which was the predecessor to C. So he's a pretty cool guy. And so they've got these smart guys together, and they decided we need a new language because we don't have anything to handle the concurrency that we need. We have multiple core processors, but we have to use pthreads and all this other garbage. I mean, really, it's a pain in the butt. So these are their design goals. It's a compiled language, but they want it to be fun and easy. So usually fun and compiled don't go together, right? We think of C, C++, or I don't know, maybe some variants of Lisp. But Go is supposed to be fun and easy. It's garbage collected, very concise, supposed to be simple syntax. So they use a term called orthogonal language or orthogonal syntax. Anybody know what that could mean? No. I'm just kind of guessing out here because I took a linear algebra class. I'm assuming there's some kind of overlap, but it means like there are features that just barely enough features to get you by. There's no overlap. You can't do like the same thing 15 different ways. It's pretty much one or two best ways of doing it, and that's the idiomatic best way of doing it. Sure, there are hacks you can get around it, but they're trying to gear you towards the best way of doing it. All right. So some syntax basics to keep in mind as you look at the code and stuff. First of all, they don't have access modifiers directly. They're all implicit by how you capitalize your functions and your variables. If it's capitalized, it's exported. So like in C, or not C, and like in Java, you have your private instance variables, and you have your public instance variables, your private methods, public methods. Here it's capitalized as public, lowercase is private. There's good things and bad things about that, but that's just how it is. These are kind of flopped. You usually think of int A, but in Go it's A int. Identifier name, identifier type. So yeah. Colon equals means you're going to declare something and initialize it. And that's going to infer the type of whatever's on the right-hand side. Equals just reassigns the same thing over to a different value. And everything is namespaced. Like if you import something like in Python, you get like everything's in your namespace. You're like, oh, I imported this one module, now I have 20 free functions. No, this one you do module name dot something. All right, so here's Hello World. As you can see, it's namespaced. Import fmt, the format package, fmt.println, and you do something with it. Your main method has to be in package main, and if it's not package main, it's a library. If it's package main, it's an executable. So make sure you have a package main if you want to run it. Then there's the go command. Anybody here use Ruby or Node.js? Or use like gem or npm, something like that? This is similar. Get is like your install command. It goes and fetches a URL somewhere and installs it. And then you can import it anywhere in your code. Run runs it kind of like an interpreted language. It doesn't produce an executable. It just compiles it and runs it in memory. Test runs unit test. And there's also build, which will build the executable. Semicolons are optional, but they're technically there. Like in JavaScript, where they just insert semicolons randomly. That's kind of what they do, but they do it a lot better. Like, you don't get syntax errors because you forgot a semicolon. So semicolons are always inserted at the end of a line if it is ended with one of those things. Identifier, literal, token, or one of those ones. Nobody uses them, really. Like, I've seen code like with like 5 semicolons in the whole program, something like that, and most of them are in for loops. So, yeah. Here's your control structures. Notice there's no when, oh not when, no while, just if, for, and switch. There's also select, but it's not really a control structure. So your if, pretty standard, just subtract the parentheses, kind of like, I guess, Python, kind of like that. This one's a little bit interesting. Error and R, these are declared in the if-else block scope. So they're not accessible outside of the if-else, and you have to have some kind of a Boolean expression at the end. So here I'm saying, I'm going to declare these to this thing, and then if error is not nil, then do something with it. In this case, throw an exception. We'll get into more about exceptions and stuff like that later. Okay. So for, infinite loop. Maybe infinite loop, depending on what you do with it. It's just like a while loop, and then a traditional for loop. This is really useful when you talk about stuff later with concurrency. You'll see that later. Switch statements. If you don't put a condition in here, then your case statements just need to evaluate to true false. It's like a big nasty if-else block, but organized. Case statements don't fall through by default. They break by default. So you don't have weird bugs where you fall through to like, oh, here's a good case and then error case. Throw an exception. What? No, it's successful, whatever. But here you have to explicitly say fall through. So you can fall through, but you have to do it explicitly. This one's kind of interesting. With Go, there's no casting. All you can do is a type assertion that basically says, give me that type or throw an exception and crash my program. Here's a little more safe way to do it. Say, I'm not sure what this type is, but I'll accept these values, and my default is maybe throw an exception or something like that. So so those string, int, and my type, those are all types that either you defined or have been defined by the language. So like I said, type assertions are not the same as casting. Like in Java or C or something like that, you might get a casting exception. In C, you'll probably just get some garbage. I don't know. It just depends. But in Go, it'll be a runtime exception if it's wrong, and you can't cast to something that isn't that type. It has to be declared as that type and just hidden as like this weird interface thing. It's kind of like a void star in C or the object in Java or something like that. Okay. Arrays, they're cool. Don't do this ever. It doesn't work. All that does is it creates an empty slice where the data behind it is nil, which is useless. This one creates an array, and a slice is like a window into an array. So like in Python, D, I don't know what languages have them, but it's like a window into it. You can pass them around and manipulate them, and that'll manipulate the underlying array, but the slice will only know about its length, its bounded size that you gave it. And the bottom one, right here, this little ellipses is kind of weird. I've never actually seen anybody use it. That basically says, I'm not sure what the number is, I'm too lazy to type it in, just grab it from over here. And initialize it at the same time. The interesting thing is that this array, array 5 int, is not the same as this array. There are certain situations where it will not be accepted by certain functions. Not entirely sure why they did that, but just know that if you're going to make an array, most people do it this way. This one is okay, this one's okay, but this one's the one that nobody uses.
So make is a keyword, is what you're saying.
Make is a keyword.
Is a keyword. Mm-hmm. The third one is making an array of 5 integers.
So these two are functionally equivalent, but they don't produce the same thing.
And they're initialized as 0?
Yeah, unless they're explicitly initialized.
Right, okay.
So this one right here, new is used for other things like structs, and that will return a pointer to whatever data type that is. So it puts it on the heap and it gives you a pointer back. These ones give you a literal, static array or something like that. So if you pass it into a function, it'll be copied. It won't be passed by reference. This one, since it's a pointer, the pointer will be copied, so effectively you're passing by reference. There's no arrow syntax I can see. Everything is dot, so there's really no difference between a pointer and not pointer, just when it's passive reference and when it's not. It's not a big deal because if you pass a slice in, it's basically a pointer. So that's what everybody does anyway.
still a little confused about the difference between an array and a slice, and then also why a new array is not useful.
Okay, so this new array, what that's saying, I don't have a pen, but it's saying that I want to create a structure that's an array, but underneath it there's nothing in it. It's empty. It's initialized to nil. That's what that data type is.
You're saying it's not default initialized with any value.
Yeah, you could actually create something inside of it, but that's just more work, and it's not useful. It'll give you a pointer to a nil array, which is not the same as an empty array. It's nil, meaning there's nothing there, void, whatever.
Did you initialize it later?
So
You
there's
could.
5 pointers to 5 integers.
Yeah, but that's not the idiomatic way of doing it. The idiomatic way of getting a pointer to an array is to make an array and pass a slice to it. A slice, like I said, you have this big array, and you give it a little window into it. The window can be the whole array, or it can just be a little small segment. And actually, we'll be doing some fun with slices a little bit later. So, just kind of think in your mind, slice, window to an array, kind of like a C array, except that it knows how long it is. Okay, slices. Changing a slice will change the underlying array. Arrays are statically sized. You can't expand or contract them, but you can append stuff onto it to create a new array. So it's like concatenating 2 arrays together and you get a new array. It's a different allocated array.
Doesn't include the last index, right? It's non-inclusive.
Yeah, that's right. So 0:5, that gets a slice from 0 up until just before the index 5. So if you wanted to have half and half, you do this len. Len is also a built-in command. It gets a length of whatever it is, usually an array. You get the length of that divided by 2, and that'll be halfway through it. So this way here, we'll split it up into f being the first half, L being the last half.
Those are just views into the back end array.
Yeah, so if you pass those into a function, and then they get assigned to, the values inside change, that'll change the original array. So it's really nice if you want to have this huge array, like say it's like 20 megs, you want to split it up into 1 kilobyte chunks, and throw in a bunch of processes and do all the work on it separately. Super simple and super efficient. Cool? Still with me? All right. Maps. They're kind of like JavaScript maps, or I guess you could say dictionary in Python if you guys are familiar with it. It's basically the thing inside of the square brackets. That's the index type, and then the other one is the value type. So if you wanted to emulate an array, but it was expandable, you could make it a map of an int to a string or something like that. So JavaScript is awesome, Go is awesome, Visual Basic not so much. All right, so if you want to get something out of it, you just grab by the key. You can use a string if it's a string type, like a string literal, or you can use something passed into a function. If you want to know if it exists, because if it doesn't exist, it'll give you the 0 type of that value. So if the value is like an integer, you'll get a 0. If it's a string, you'll get an empty string. If it's a pointer, it'll get a null or nil. But if you put a second parameter onto it, then you can get a Boolean that says it's there or it's not. So kind of useful, especially if you're managing lots of different clients and you want to know if that client is still connected and it might have been removed somewhere else in the code or something like that. Delete a key, yeah?
What's with the underscore?
Yeah.
Oh yeah, I almost forgot about that. The underscore is just a way to say, I don't care. Throw that value away, whatever, I don't care, I'm not even look at it. You don't have to worry about an extra value in there, cluttering for namespace or anything like that, or an extra identifier. It just says, all I care about is the Boolean, whether it exists, throw away the value. It works also for return values from functions, and anything where you have to assign something to something.
So if something returned 3 or 4 values and I only cared about the one in the middle, but I just do underscore, comma, var, name, comma, underscore, comma, underscore?
Yeah, underscore, comma, like identifier or something like that, yeah.
So you can use underscore multiple times.
Mm-hmm. It's a part of the language. It's not like you can later on do underscore and assign it to something and use it. It's one of the few special values there.
Does that work with initializing as well, or only with assignment?
Initializing, like
So the colon equals?
yeah, it does.
Okay.
So as long as so the colon equals, if you have one of the things in that list to the left-hand side of the equal sign, if one of those has not been declared yet, use a colon equals, otherwise use equals. And if you don't care about a value, underscore will get rid of it. And to loop over stuff, then you have the range keyword. Oops. So you have the range keyword. That works for arrays, works for maps, and it also works for channels. We'll talk about channels later. But yeah, that's how you loop over something. Key is whatever your index is indexing by, value, yeah. So functions. This right here, this tells what type it's attached to. So you can attach functions to a type. You don't, like in other object-oriented languages, you'd have like your class and you have all your functions declared inside. Here you just declare your struct and then the functions that you're going to attach to it. Then you have your arguments array and then as many return values as you want. Usually it's usually 2. I actually got them backwards. You're supposed to have the error on the right-hand side usually that's how most of the standard library does it. But I did this at like 2 in the morning, so I'm like, whatever. So
It's like JavaScript standard.
yeah, but you can do whatever you want. I mean, it's not going to throw any errors at you. And here I've actually named them. If you've noticed, I didn't have to instantiate them at all. They get assigned the default values for that type. So, yeah?
Oh, I'm sorry. What's going on with the S and the...
Oh, yeah, this. Yeah, that's when you attach it to the type. So the T is the type I'm attaching to. So for the next slide... Oh, wait. Did I miss? Yeah, so you have your struct, and then you want to attach something to the struct. So you have struct myType, and then your myType might have maybe an integer and a string and a map of some sort. Then you just create a function, myType, and then this is the variable you want to use it by. And then inside that function, you do s.something. And then that something is something that's attached to that function, or that struct.
So, in other words, for lack of a better term, the S pointer, the S asterisk T is the this pointer?
Kind of, yeah. So instead of using this, you do S or whatever you want to call it. Yeah. So it's a little bit different thinking from other things. But one of the ideas there is that there's no inheritance really in Go. If you implement an interface, you are that type. So it doesn't really make sense to attach them to the class because then you'll want to subclass it and do other things. And that's just how the syntax is. I don't think it's all that clean, but they're smarter than me, so I figure it's good in the long run, right?
So if I had a function speak, a person and a dog and a parrot, and they can all speak, I can use the speak function with all of them, or I have to implement a different...
You'd use a separate speak function, but they could all be passed around as something that speaks. Like you'd call your interface a speaker, and it'd have a function speak, and you'd have 3 structs, dog, person, cat, or whatever, and then they have a function called speak, and then they can be passed around as a speaker. So they'll have different implementations, but they'll do the same thing. So if you do have because sometimes that causes a little bit of code reduplication, but for a lot of things it's not that bad.
Because normally you don't have a bag full of dogs, people, and parrots.
Yeah, that speak. Yeah. Defer. Yeah.
Just for history's sake, do you have any idea why they switched the variable and the type, or the type after the variable?
I really don't know. I thought it was the weirdest thing ever when I saw it. But I guess you don't really need the type most of the time. You just do b : equals something.
Right.
So it just makes the syntax more,
Which
I guess.
is for functions?
Yeah. You can actually have,
For return.
if these are both integers, you could do a, b, int. And they'd both be integers.
Right, 'cause
But
we use this.
yeah, I guess the idea is that you can leave off the type if you're assigning to it, so that way it looks kind of the same. I don't know. But that's just what they do, so you'll get used to it. Defer. Defer will always be called before the function exits. Always. Doesn't matter what happens, it will always get called. So if you have to close a file handle, you open it somewhere, and then right after you open it, you call defer filehandle.close or something, and don't worry about it anymore. I mean, your code could go off in 10 different branches, and it'll always get called. In this case, this is functionally equivalent to the hello world example I showed earlier. First, you print hello, exit the function, and as you're exiting, print world. So if you can think of how that could be useful in like handling errors and stuff or whatever. And
You have multiple defers in their conditional, like if such and such defer, if such and such defer, will they be last in, first out?
I think it's first in, first out. I think it goes in order of when they're put on.
Kind of
But
transaction backing out.
Yeah, I'm not entirely sure of the order. All I know is that they always get called after the function exits.
It would make more sense to have them last in, first out.
Yeah, which might be what they do. But oftentimes the functions are pretty small, and you don't have like 50-line long functions with.
Oh, sure.
Yeah.
But it's not unusual to have a
Yeah.
small multi-part, something that you want to do atomically.
Like you might open a file handle, open a stream to that file handle. You want to make sure the stream closes before the file does. Yeah.
So defer is kind of like go-to cleanup in the old dirty C.
Yeah.
Yes, there are AI answer.
It's a lot. Yeah, it's just like that. Yeah.
Like finally clause in Java.
Yeah, like if you have like your try catch, and then you have this big nasty whatever, 15 catch statements, and then you have your one finally. Same idea.
D has the scope statement.
Yes.
And that's what's nice about it, is that it goes in last in, first out.
Yeah, and I love D, by the way. One of my favorite
Good
languages.
choice.
Yeah.
Question.
Yeah.
You can do non-blocking stuff.
Technically, but the idea is you don't need to, because we'll talk about concurrency later, but like the way that it handles multi-threading is really cheap, so it's not really a big deal. Okay, so if you have an exception, which you shouldn't ever have, but if you do, you can recover from it. So panic is like, think of it like a kernel panic or blue screen of death. You don't ever want to see that. But if you do, there's a way out. And you put this somewhere in a stack frame above it, in a defer statement or something like that. You can defer an entire function or whatever. But I would recommend, if you have production code, to put this at the top level of every single Go routine. Because if any one of your Go routines, we'll talk about those later, but if any one of those doesn't handle a panic, the entire thing goes down. Like the system crashes and everybody cries. Not good. But you shouldn't ever see it, and don't ever panic unless you really, really have to. Like, for example, oh no, there's no root user, I can't do anything. That's a reason to panic. But not like, oh no, your integer was less than 5 and I expected it to be greater than 5. That's an error, not a panic. So, and you'll see, since you have multiple return values, it doesn't matter. You can just return an error. You don't have the weird garbage of in C where you have the -1 return value means it's some kind of error. Then you go check error node to see what error it was. Maybe you have to go check something else to see what actual error it was. No, it's none of that garbage. It's all handled with return values and panics if you really have to. And variadic functions, they are almost as nice as D's, but they are pretty nice. Like, you just say your type and then preface it with the ... That means I could have 0 or infinity of that type. And to call it, you can call it individually with numbers or with your types, all in commas or something. Or you can pass in an array and throw the ellipses after it. These two are equivalent. Except that I think this one actually has to allocate the integer first and then deallocate it. But yeah, same idea. So you can do variadic type things. Like that's kind of how like printf and all that kind of stuff work.
With the ellipses in the second version, is that something you're saying to the array, or is that something you're saying to the function?
It tells the compiler that the thing you're passing in needs to be separated out into Variadic style were actually, I guess, put back together.
So it flattens them out.
Yeah. Conceptually, I think actually internally it passes an array, but conceptually it just flattens them out so it looks kind of like this. Because most of the time you have a variadic function, you'll call it like this. Like printf, you're going to call it with a whole bunch of parameters. But if you wanted to, like say you had a big nasty printf function and you wanted to store everything in a big array just to make it cleaner, then you could just go ahead and use ellipses and you're off to the races. Okay? Any other questions about that? Okay. Custom types. I kind of mentioned this before. Declare the struct, attach something to it. And then this right here, this area, is actually a private function. If I capitalize it, it'd be public. This width and height are public, so I could do whatever my square pointer is, dot width or dot height, and I'll get the values. But if they're lowercase, it would give me an error saying I can't do that.
Wait, so if that function is attached to the type, why wouldn't it be able to access the type?
The function can, yeah, but if you're calling it from outside. Like if you create the struct and you have a lowercase something here, that'll be callable from within here, but not from some other function. Yeah. Interfaces, I call it duck typing, but it's not really. It's close enough that I don't really care. If you proclaim yourself as a type, you are a type. And actually, we have a little quick example here with the appenders, with my little appender. So I have this actually on my gist on GitHub. It's not too interesting, but if you want to pull it down, you can. Basically, I created a type that's got some kind of a buffer inside, and then I have a write function. This satisfies this type. This type is used in the system for all kinds of stuff. Like you could pass this into fprintf or something like that, or sprintf or anything like that. So you could pass your type in anything that uses a writer interface.
This looks like duck typing to me. Oh, this specifically? Because this doesn't say writer anywhere.
Yeah, it doesn't say writer,
But it has the right.
but it has the right function.
So that's duck typing.
Yeah. But usually duck typing, like you can, I don't know, maybe traditionally, like with Ruby and stuff, you can attach functions and it becomes a type. I don't know, maybe it is duck typing. I'm not entirely sure on
It's the essence. Duck typing
Yeah.
means
Duck type just fulfills the
Yeah.
if it has
It
implicit interface.
Yeah, it's basically duck typing. It's not object-oriented. That's the main pull away here. Take away, yeah. So, yeah, as long as you return the right types, you're good. Concurrency, our favorite part about Go. Okay, so with concurrency, you have your Go routines. It manages a thread pool. And say it decides to allocate 4 threads and you have 10 packets of code that need to be run. It'll schedule that on the threads as they're available. So if 2 of the tasks block, then the other threads can be used. And they'll be pulled off and wait for until they respond and stuff like that. So it's kind of asynchronous because it doesn't use a thread per Go routine, but it's not because it uses actual threads, so they're running at the same time. So it is kind of parallelism, but it is true concurrency. And the difference there is an argument that they have on the internet all the time. But all you need to know is that when you call something with Go, puts it into a new Go routine, and does it at the same time as you're currently running code. So, yeah, channels are the way to communicate. But let's just actually have an example first before we get into that. So I have my code here. If you want to follow along, it's just on a gist on GitHub. But this is just a really simple program that takes a big array of numbers, in this case 100 bytes, or 100 bytes I guess it is, or integers, and then it splits it up into 10 chunks and randomly assigns numbers 0 through 100 to those ones. Well, not randomly, but it assigns all the values 0 to 100 in order, but as the Go routine requests them. So here we have a seed. Since I didn't really feel like generating some entropy, we have to use just a fake pseudo number generator. But use the random thing, just pull out stuff. This is all pretty simple, like grab the arguments from the command line, parse in an integer, and if it's not there, give it a default. If it is, do something with it. But the interesting part is when we get down to here. We're going to make a channel. So a channel is like a buffer that's shared between Go routines. And you can shovel stuff both ways. And you can give it, either it can be a blocking buffer or it can be a non-blocking buffer. So blocking buffer is just a 0 element buffer. So you shovel something in and you have to wait until the person grabs it back out. It's like handing someone a tray of food or something like that. You have to wait for them to pick it up before you let it go. But if you have a non-blocking buffer, you have, say, 5 elements in it. You can put 5 things on a tray, and then you have to wait to put the 6th one on because they have to pull them up to make room. So that's all handled for you. And in this example, I use this parts parameter. That parts just means divide my integer array into this many parts.
So that's a keyword?
I just made it. It's a constant. Right here.
Oh, okay.
Yeah.
Parts 10, yeah. And this number is global, and it will be used by multiple Go routines. So it's going to show that it handles all the mutexing and stuff like that for you. You're not going to get any weird race conditions with that. So you're not going to get like one.
So you can share.
You can share.
Implicitly?
Yeah. And it's all done by lexical scoping. So you could have closures inside closures that run a couple Go routines, and they'll all have a stuff that's accessible outside of it.
So you don't need to do locking. You know, we're used to doing probably done locking
Mm-hmm.
on when you have to share variables.
Yeah, like you throw up a couple semaphores or mutexes or whatever.
So
No.
you're saying you don't need to do that. You
Mhm.
modify one, and now all of them can see it. And you don't need to do any kind of semaphores around it.
Yeah, the whole pthread library is out the window. We don't need that anymore. We don't need mutexes, semaphores. It's all handled by the runtime. Internally, it uses semaphores, of course. You have to, but
But it does it.
yeah, the code, you don't see anything like that. The closest thing you have to a semaphore are these channels. And they're a lot better, a lot nicer to work with, if you ask me. You don't have to have weird checks in there. So back to the example. This is just right here. Okay, we got this. This channel is a channel with 10 elements in it. We're going to make 10 Go routines. So when it gets filled up, then we're going to be done. And this one right here is our done channel. I just threw that in there. We could have put all the code from this go listen function into the current scope, but I figured it'd be nice to have it in here. So we make this channel, and we pass it, first of all, the channel that the other Go routine is going to be using, and we pass it this Boolean so that it'll notify the calling function when it's done. And if you might have noticed, I have this go function, so we know that's going to put that on the thing to do and keep going. And here we have, I'm just doing a simple count, which counts the number of things until I get to the number of parts. And it prints out. And this little line right here is the kicker right here. So that little arrow means I'm going to pull out from the channel the next value. It'll block until something's available. So it'll just sit there and sit there and sit there until someone pushes to it. And then when it does, pulls that out, sticks it in the printf, increments the number, and then goes back into the loop and waits again. All right, and then we have in here, I break this up into chunks, do my nice slicing, just pull out first part of it, then the beginning of the next part, and so on. Pretty standard. Then you do go fill random. Okay. So fill random, you go loop through the array, and then you just write this number, and you increment it right afterwards. So write it, increment it, and then go down. There's a small chance for a race condition here where you could increment it at the wrong time, but it's not a big deal. I mean, they'll get the right number eventually. So you might have 1 or 2 bad values, but I haven't noticed anything yet. Then here, you have a random number, and we're going to sleep for anything between 0 and 100 milliseconds.
Can you do embed the increment like you can in C? Like in line 19, could you say erase of I equals num plus plus?
I don't think so. I got a syntax error on that, I think. I think I could probably do it if I maybe wrapped it,
Well, I'm just trying
but
to understand.
how you'd make it
You
more.
kind of mentioned really briefly about a possible race condition.
I think
Between
it
the
might.
assignment and the increment, is that what you were talking
Mhm.
about?
Yeah, but this is kind of a contrived example, and I guess you could probably see this in real life. But I don't know. Like,
I guess the question is, how would you?
even if you did do the plus
Stop
plus
the
after it, it would do the first command. It's not atomic, so it would do the first command,
Okay, that was.
and
my
then
question.
yeah. So even in C++, it wouldn't work. But
Well, I know it wouldn't.
you'd use a semaphore in that case.
Yeah.
Yeah. So if you really want to do that, you could throw a channel above and below, where it has a one element, and you write to it, or you do like a little fake semaphore where you write to one, and then you have other people wait on it, and then you read on it, and then when someone writes to it, then you go and do one.
So you still have a way of doing critical.
So you
sections.
could, yeah, you could still do critical sections with channels, if it's really that important. Yeah. So yeah. So do you want to run this code and see how it runs?
What is it supposed to do again?
It takes a big array, splits up into chunks, puts those chunks into different Go routines. It's kind of like taking a huge data file and processing different chunks at a time. And then those are all slices. And then
So
for
it's
each
still a
loop,
big array.
yeah, for each loop, it will assign it'll assign the number that's in the global scope, increment it, and then go back and do it over and over again. So that way you'll get the numbers 0 through 99 randomized through the entire array. Yeah, but if you could do something more complex, like doing some FFT garbage and do a whole big data set.
So you're assigning a random number from 0 to 99 through this.
Yeah, I'm basically taking one array, splitting it up, and randomizing it. Where did I put it? Oh dear. Don't know where I put it. You can see all my nice code here. Let me see. Okay, this one. Concurrent.
Or copy and paste into
Yeah, I could do that. Sorry about the wait here. I mistakenly rebooted my computer and I forgot where I stuck it. Okay. Is that faster? Right. Okay. We've got ourselves concurrent.go. Okay, let's go. So like I said, the go run, that'll just run it, and we'll get something. Give it a seed number, and
That's right.
I need to fix my syntax there that I forgot to fix last time.
Find seed.
I forgot what the actual error was here sometime, but didn't like that. Okay. Cannot assign to seed. Multiple assignment. Okay. There we go. Okay, as you can see, it did. Let me make this bigger. Okay, it did all the channels in pretty random order, as you expect. And these numbers are in also pretty random order. And as you can see, it looks like there's most of the numbers there. If I use a different seed, then we'll get a different set of numbers. But if we use the same seed over and over again, we'll probably get the same set. But yeah, so that's basically how concurrency works, is you have those channels. Each one of those, these fill randoms, after they finish writing, they write to the channel. That n is being shoved into the channel, which is being read out here. And then when you reach 10, or the number of parts, then you finish. So that's a basic example of how it works. Of course, in real life, you'd probably be doing something like multiplexing some file I/O or something like that. When the file is done, then you'd send back a message saying, okay, I'm done, give me the next file to read or process or something like that. But that's basically how it works. You send it a channel, feed some stuff over the channel, read it back on the other side, and keep on going. And you can go both ways. So, yeah. So any questions about that example? Is it really confusing?
Yes.
Okay. So, yeah. Idea is chunk, break it up, process each chunk, put it back together. But with using slices instead of having to rebuild an array, and using Go routines instead of having to do SD multiplexing.
Did you pass a slice to each Go routine?
Yes, I didn't show you that, did I?
Yeah.
Okay, here I made a slice,
Okay.
and I have an array,
Right.
just like in D.
So you did.
Yeah, and I have the slice, and then that slice goes in. And since slices are windows to an array, they're passed by a kind of a pointer because they're not really a data type. And when you update them, then it updates the
So
virtual array.
this allowed you to simultaneously populate that array
Mhm.
with random numbers with multiple channels
Yes.
working concurrent.
In 77 lines of code. I mean, I could have done better,
Yeah,
but
could have done better in
but
D too, but that's okay.
it's okay. I would have done stuff about D, but
No, you did a good job.
Yeah.
This is good.
I wish D had the little Go function. Instead, you have to use the
Yeah.
parallels and package and all that. But
Well, or you can just use threads and message pass.
okay,
So a couple questions. Does
Yeah.
this scale past one machine? You know, can you have a cluster or something of one
actually, I thought no, but I guess yes. There's a package called RPC, which allows you to send data across the network to another Go app, and you can send an entire function, and it will go ahead and compute that for you. So it's a way of linking together stuff with a thin layer API.
machine? Is it pretty seamless, or do you have
It's
to-
pretty good, yeah. Like PKG.
The question to queue it up is, does Go interact with other languages, or would I have to rewrite my functionality to use this?
You can import C into it if you like, or C++. It's a statically compiled language. So you can't call Go from within C, but you can call C from Go. That process it's possible. It's not that bad, but it's like a lot of the standard library is done that way. Like all the file I/O stuff is all done with whatever the operating system does. There's also like doing message passing to the kernel, where you say, "Tell me when this file has been modified," and stuff like that. Like iNotify or whatever you have in your system. But so it does call C code, but it pulls all that into one executable. So that might be a deal breaker, might not be. But so how about getting on a web application, a really simple one?
Could I see Phil random
Yeah.
really quick?
Where am I? Fill random.
Oh, okay, never mind. I'll look at it next year.
Okay. So the one we're going to build is
Okay.
a simple chat client with WebSockets. Fortunately, there's already WebSockets packaged, so we only have to look at like 70 lines of code again, so it's not that bad. So let's go back. I'm just going to briefly hash over some of the frameworks in here too that you can use. Okay, Go routines. Hello world, this is a simple web app. This is really all it is, to serve some kind of static text or something like that. http.handlefunc, that says when I get slash, do that. http.listen and serve, when you go to port 8080 or localhost 8080 or your domain colon 8080, then nil, we'll talk about what to do with that nil later if we want to use it. But if we get slash, we'll go here, and that's it. Simple as pie. right?
So is this just a single thread?
Each time this gets called is a new go routine.
But for every hit to the TCP 8080, we'll get a separate thread, is that?
Yeah, separate go routine. Like you might have 4 threads and 50 go routines. So they're all multiplexed, yeah. They're not multiplexed, but yeah, you know, queued. Scheduled is a better word. Here's a more complex example, slightly. Create a new server. Server is just a type that you create. It's something special. So I just create a type called server. And all it has inside of it is, well, nothing. All it has is just this function. You pass that in where the nil was in listen and serve. And now you can handle everything yourself. This request right here, that has all the things you need. It's got the URL, it's got the query parameters, the headers, it's already parsed the form for you and stuff like that. Your writer is like the writer we just wrote. Same API. You hand it bytes and it flushes out to the stream. That's it. So you can use any of the packages that use a writer with that. Pretty cool, I think. It's like Java's abstraction, but with less abstraction. So, yeah. Web frameworks, web.go is one of the first. It's also one of the most popular. Mango, it's popular, haven't looked into it. Web.go is really simple. Like instead of doing that handle and serve, you could do like web.go or whatever the web.get. It'll do a get request, respond to a get request, or post, or respond to a post request. It's not that hard to make your own. I wrote my own in like an afternoon. It wasn't that bad. But it has some cool features now. Database drivers, these are the 2 I use. I've used MGO for Go. I haven't used Redis.go yet because I haven't had an opportunity to need it. But this one's really good. It's made by someone over at Ubuntu, or at Canonical. So it's pretty good. Here's where you can go to find all the pure Go libs. And they're usually really clean code.
Have support for other major databases?
Yeah, like CouchDB,
Oracle and stuff.
SQL. There's an SQL library within the standard library of Go. And there's plenty of drivers for whatever database you'll need. They've been pretty studious about figuring out which ones people actually need and getting those implemented. This is the one I created. I think it's cool. I don't know if you guys will think it's cool, but if you guys have ever used Node.js with Connect or Express, it's similar. It's got similar routing rules to Sinatra or Rack. You can do regex, or you can do or identifier-based stuff. The idea is you have a big stack that it goes through, and you call each function one by one until one of them returns true. If one of them says, all right, I finished the request, then you just stop the loop and you're done. So that way you can have like your authentication in one part, then you can have your parsing of the user input in one part, then you can have your database transactions in another part, and so on down the stack until you get down to the actual serving of the page. I like it because I made it so that you can have different files, and they're all one package, but they're all compiled into one library, and there's an API for creating your own module. So if you want to look at how to do something like that, if that's something that interests you, feel free to look it up. It's on my GitHub. Packages, it's like Java, except you have to have a main package and then any other kind of package you want to name it. Like for Artichoke, you name it Artichoke. For web.go, you'd name it web. For Mango, you'd use Mango. And then you just import the URL to that repository if it's on GitHub, or if it's on Google Code, or if it's on somebody's server somewhere out in Africa or something, then just use the URL to get to it, and then it'll go ahead and compile it for you and pull it down for you with GoGet. All right, let's get to the fun part. Okay, so we have, this isn't my code, just so you know. I was going to write one, but this was done and it worked, and I liked it. So first of all, we start out with the hub. This is where everything kind of connects together. You've got your hub, and it's got some channels and stuff, but this right here is the important part. This is where it calls and assigns these values. Kind of like in C, you just list them one after another, and they'll be assigned one after another down the struct. So the broadcast channel, this is where you shove strings to be shoved out to everybody else. Your connections are when somebody connects, etc. And there's another channel used somewhere else that will let you pull stuff in. So like a receive from the client. But this one's broadcast. When you receive something from the client, you push it out. Down here we have, this is the main run function. This is running a Go routine. So it does an infinite loop where on each iteration it halts on the select, kind of like in Unix. And then whichever one of these responds, it will execute that, exit the select, come back around and do it again. So if it gets a broadcast, it'll go through and shovel this out to all the clients, come back around and wait for another broadcast. Or if somebody registers with a WebSocket, or unregisters, it's all handled in that function. It's like a big multiplexer. You pass in a bit saying, this is the channel I'm communicating on, so go and execute that, and then wait again. And this is key in like all multi-threaded stuff in Go. It's a lot simpler than trying to do some UTOSC or something like that. Later on, here's where you use the WebSocket code. Reader pulls stuff in from the client. Writer writes stuff out to the client. This is just a syntax for the WebSocket API that they have there. And the WebSocket API is supported on Chrome and Firefox. And there are solutions available if you want to do Internet Explorer type stuff with WebSockets. If it doesn't support it, it'll implement it for you. So, okay. And this just registers stuff, starts all the things. Well, that's the WebSocket handler. Okay, this is the one that, okay, here's the main function. Remember that run function we saw with the crazy multiplexer? That gets called here, so it waits until there's something. Handle stuff, this will just serve the home page and whatnot. So do you want to see it run? All right. I probably can't find it. But I can go ahead and clone it. It's really easy.
So main exits while it's still running?
Main does not exit.
Main does not exit.
It exits, but the program doesn't exit because there's still stuff.
Because there's a Go routine.
Yeah.
Going.
So let's go get. We'll go ahead and grab that from that server. I'm going to go ahead and clone this.
So go get handles like imperial, git, svn.
Yeah, it just grabs all the things.
All of them.
All the things. Like, they don't have everything supported, but anything that anybody feasibly really uses is supported. Like, I'm sure that if you use, like, I don't know, something you made up yourself in your garage, it probably wouldn't support that. But it supports HTTP, and that's an FTP and stuff like that, so that's about all you really need. Okay, so we're in here, and so we've got all our files here, the con, hub, main. And if we go ahead and run that, it'll start on port 8080. And if we go to 8080, here we have our web client. Nobody's connected. I'll go ahead and say hello. And since I'm a client,
Yeah, let's see how concurrent it is.
let's do it. So there we go. 161.128.254. I'm going to post this on the WebSocket.
Wait, that's what you're like?
That's what it says. Okay.
Firewall to head back, but yeah.
Okay, does everybody have that? Where I just ban my computer and crash it?
Try it on a different port rather than 8080 because the firewall might not like.
Yeah, run it on 80.
80? Okay.
I recognize that sound anywhere.
Okay.
I don't see if there's any security vulnerabilities in
Let's see if that works. Can you guys get to it? No?
I can ping you.
It's not hitting any.
You have a firewall on.
Actually, I might. Let's see.
What have you tried by accident?
That's my password.
Okay. Okay, it's disabled. Go ahead and hack my computer. No, I won't apply that actually. Okay, now I have no firewall. Let's see.
There.
Am I on? Yep.
There's one first.
2825412. Can I ask you a question?
Yeah.
What,
ASL.
Wait, which one was that? I didn't. Yeah.
could you summarize? I feel like I'm a couple steps behind you.
Okay.
Capability.
Do you want me to summarize the WebSocket part or the Go?
Could you summarize some reasons why you would pick Go over like using Node.js?
First of all, it is compiled, and that is a big plus personally for me. With AJ, we work with embedded devices, and we need things to start up fast. With Node.js, I mean, you shouldn't be running Node.js on an embedded device, but we do, and it's cool, but it doesn't start up very fast.
Why would a web developer choose Go?
A web developer, another reason, I guess, is if you need to process lots and lots of data, like say you're going to run some kind of a math site where you want to have an interactive math number crunching site. That's going to take forever in Node because you're going to block the crap out of your thread. I mean, you can only chunk it up so much to make your server responsive. But with Go, they're different threads. So you don't have to do any complicated shifting or what do you call that, v-hosting between different backends. You just write it all once, and it'll all handle itself with the threads. But it's not as expensive as something like, it's a good example, I guess, Python or PHP, where it creates usually a thread per request, or a process per request. So there's no CGI. It's you're writing straight to the application, and it's fast and simple.
You think it's easier to code Go than this?
It takes some getting used to. I can admit that. Like when I first saw it, I'm like, oh my goodness, that's just like puke on a screen. What is this?
Yeah.
And then I got used to it, and then like once you figure out what's in the developers' heads, the guys that wrote this, then you can say, oh, they just want me to do it this way. They want me to be explicit about my lines, and I can't have a whole bunch of statements in one line, stuff like that. Or they want me to use Go routines instead of, I don't know, handling stuff. I don't know. Like it's a different paradigm. Like defining types. Like you can define a type thing, and it could be an integer, and then halfway down the road you could change it to a float, and halfway down the road you could change it to an int64 or something like that.
Can you see the web development community adopting Go realistically?
It is used for Google App Engine, which is a huge plus. Google App Engine supports Python, Java, and Go. If they support Node.js, I would think maybe there wouldn't be as much hope, but since they don't, then I think Go is actually going to be quite tempting to a lot of developers, especially as it matures. It's also, you can use it for web development and for other stuff. So you're not just stuck with a language just for web development. Like I wouldn't use Node for writing a driver for something, but I could conceivably use Node Go for that.
I've written a driver with Node.
I'm sorry. I wrote tar in Node too, so I guess I'm whatever.
I was just opening up something like /dev or /sys and then putting characters in it. So
Yeah.
it was a bit big driver.
What kind of support is there for talking to two different Go instances, like two different Go instances on two different computers talking over a network?
Yeah, I mentioned that before. It's called RPC. It's in the standard library, and you have to define your function with 2 parameters and 2 return values. One parameter has to be a pointer, and the other one can point to whatever you want, and the other one has to be something else. But then, if you abide by that rule, it can ship everything off to your other process. So say you're running a small cluster at home and you have your big monstrous 15 or 16 core machine, and then you have your little ARM machine. So your ARM machine is good enough for serving web pages, but it's not good enough for doing some image stuff, like image manipulation. So you shove all that stuff off to your big beefy computer, it responds just over a channel or something like that. So it's pretty simple. I haven't dug into it, but there is support for it.
Is there a TCP library available?
Yeah.
Have you used it? Is it as good as Node's?
There's the net module, and then beneath that there's the HTTP module. So like Node, it's kind of built on top of it, but it's basically the same idea. Like how you'd use the HTTP one, it's the same idea, except you don't have that request object. It's just a byte array or a stream or something like that. Any other questions, points of utter confusion?
What's the language that Google was hoping would replace JavaScript?
Dart. Yeah. Oh, another thing that's kind of cool about Go is that it built in an HTML/text templating engine. So you don't have to use something else. Like there's like 15 templating engines out there, and they all compete for different spaces, but they haven't built into the language where you can pass a Go object into it, and it'll assign all the things over to your points in the template. So if you wanted to, you could take someone else's template engine, write a compiler to compile it to the Go template engine, and ship it out the door. And you don't have to do any, it has all the HTML parsing for you, but actually HTML it was excluded from the 1.0 release, but in the 1.1 release it'll be there. But it's pretty snazzy. I wrote a really simple Jade parser in Go. Took me about an afternoon, and I just took the Jade, parsed it into tokens, shoved that into the HTML templater thing, and then shipped that out the door, and it was HTML.
Where Jade is?
Jade. Anybody here familiar with Jade?
JavaScript templating.
Yeah. So
Similar to Hamlet?
yeah, so it's like a simplified HTML. You just take all the XML and you squish it into a white space limited thing instead of XML closing tag, whatever. But it was that easy for me, so I could just go ahead and write that for another templating engine if I wanted to.
Is the Google App Engine right now the only place you could probably deploy a Go in?
VPS.
Yeah, if you had a VPS, you could do it. There are packages for Arch Linux. They're trying to get one for Fedora. I don't know about Ubuntu, but it's all really easy to install. You just do a Mercurial clone, run one script, and it's installed. And that's it. So it's easy to deploy. There's Windows installers, Mac installers. So if you wanted to deploy it on a server you already have, you can. But as for a commercial solution, I think App Engine is the only way that I've found. Anything else? How do you like the example? Is that
That's awesome.
good? All right. So that code is someone else's code. I do have my slides up online, so you can get all those references if you like.
Does most of the Go community use Mercurial?
It's hit and miss. Some people use Git, some people use Mercurial.
So where are your slides?
They are. Where's my link?
Is it on the Google Docs page? Or?
Yeah, it's on right here. There we go. So the slides are at the bit.ly address right here. These are my other slides that have the link to the example that I posted. This gist is all of the code examples that I posted on the gist.
That's an LPB, right?
LPB?
LPB cry.
Which?
On the bit.ly.
Oh, yeah. LPB cry. Really?
Samantha. Jason, I've the audio.
Okay. Let's see if I can get to it. Yeah. Man, they lied to me. Oh, there it is. You might need to be signed in. I made it public.
Terry Jameson was one of the guys who was
more supported on this.
Thanks.
Thank you.
I just got an email from Lane.
Can you get to it?
Is he still,
He's at Landon.
Ours just stayed up all night duplicating.
LPB price, right?
LBBCRY.
Huh.
so you're still doing 12,000
Oh, only when I can. I actually
Yeah, thanks for coming. Here's the big nasty one. Do you have like a email address or something?
Yeah.
but I think the last time I did it.
That's the full link.
Oh no, my internet went down.
Things have been happening in the C++ world.
You want to just add the messages? Is there a change?
Yeah, I can do that. Yeah, I'll fix it so it's actually correct. I just kind of hacked it to get it working.
I would
But,
love to go. And then we'll just go with it.
okay.
Yeah, I mean, release kernels are for wins, right?
Yeah.
If you're not running the RC, I mean,